Yeah, welcome back to my YouTube channel. This is Program Mathematics. I am Moses Oluwasegun Walex, the tutor on this YouTube channel. In the last video, I explained the determinants of a 3 by 3 matrix and also explained further solving some word problem or equations involving determinants of a matrix. So today I'll be looking at the two types of matrices due to determinants. Okay, and that is talking about singular and non-singular matrices. Okay, singular and non-singular matrices. Now when we talk about a singular matrix, a matrix is said to be singular if the determinant of such a matrix is 0. Okay, a matrix is said to be singular matrix. Okay, so if the determinant of such a matrix is 0, so if A is a singular matrix, if A is a singular matrix, then the determinant of matrix A is equal to 0. Okay, is equal to 0. Now, the opposite of being singular is non-singular. Non-singular in this case means the determinant of such a matrix is not 0. So non-singular means matrix. So if matrix A is a non-singular matrix, then the determinant of matrix A is not equal to 0. So it's possible in objective questions or multiple choice questions where the question will give a list of matrices and ask you to tell which one is singular and which one is non-singular. For instance, I have two matrices here. Okay, this is matrix A. Matrix A is the set of the matrix 2, 4, 3, 6. And then I have matrix B. Matrix B is -2, 4, 3, 6. Okay, so which of these two is singular and which of them is non-singular? For you to know which is singular and which is not singular, find the determinant of each matrix. Determinant of matrix A, 2, 4, 3, 6. So this will be 2 multiplied by 6 minus 3 multiplied by 4. 2 times 6 is 12. 3 times 4 is 12. 12 minus 12 is 0. Okay, so which means that matrix A is a singular matrix. Matrix A is a singular matrix. Okay, then look at matrix B. Determinant of matrix B also, we have -2, 4, 3, 6. So what do we have here? -2 times 6, that's -12. -3 times 4 is 12. So this is -24. So matrix B is non-singular. Okay, it's a non-singular matrix or is non-singular. So when you say a matrix is singular, okay, it means the determinant of such a matrix is 0. And because of that, a question can ask you to find the value of a particular letter or an unknown in a matrix when the matrix is singular. Okay, so in this case here, let's look at an example on that. Okay, so look at this. The question says, let's call this example number 1 on this. Okay, so you have to find the value of x for which matrix A equals, let's say 3, 4, x2. Okay, 3, 4, x2 is singular. All right, so we want to find the value of, let me make this one 8. We want to find the value of x for which matrix A, which is equal to this, is singular. So if matrix A is singular, okay, what are we saying then? The determinant of matrix A is equal to 0. So to find the value of x in that case, simply calculate the determinant of matrix A and set it equal to 0. So since A is singular, then the determinant of matrix A is equal to 0. So in this case, you come here and say, therefore, determinant of 3, 4, x, 8 is equal to 0. So if you calculate the determinant here, 3 times 8 is 24, minus 4 times x is 4x. This is equal to 0. So solve this equation to find x. So 24 will be equal to 4x. Then we divide both sides by 4. Okay, so 24 over 4 will be equal to 4x over 4. 4 cancel from here. 4 here is 1. 4 in 24 is 6. So x is simply equal to 6. So if we set x equal to 6 here, then matrix A is going to be a singular matrix. Because 3 times 8 is 24. 6 times 4 also is 24. 24 minus 24 is 0. Okay, so let's take one more example on this as well. So I'm going to call this one example number 2. Example number 2. Okay, so for example number 2, we want to find, we have that if matrix X, or let's just say matrix A is equal to, is x1, 0, 2 minus 1, 7, minus 4, 2, 2. Okay, if matrix A equal to this is singular, find the value of x. So it's so similar to the first one as well, but in this case just 3 by 3. So if matrix A, which is this, is singular, find the value of x. So let's see the solution to this. You can as well pause this video and try the question on your own. So when you are done, compare your answer with mine. So since matrix A is singular, okay, so it then means the determinant of matrix A is equal to 0. So determinant of x1, 0, 2 minus 1, 7, minus 4, 2, 2. So this is 0. So if I'm taking row 1 here to solve this determinant problem, this is plus here, minus and plus. So I have x multiplied by the minor of x. The minor of x now is determinant of minus 1, 7, 2, 2. The sign convention for the second element is minus. So this is minus 1, okay, multiplied by the minor of corresponding to element 1. Delete the row and the column. We have 2, 7, minus 4, 2. 2, 7, minus 4, 2. And then the sign convention for the last one is plus 0. So the minor for 0, 2 minus 1 minus 4, 2. 2 minus 1 minus 4, 2. And this is 0. Okay? So if we simplify that further, calculating the determinant of the minors there, okay? So you can pause it and work on this as well, should you want to try this out yourself. Okay, so in this case, we have x bracket, minus 1 times 2 is minus 2, then minus 2 times 7 is 14. So minus 14, then minus 1 bracket, 2 times 2 is 4, is 4, minus 4 times 7 is minus 28. Okay, then plus, of course, the last one there is 0, so you don't need to bother yourself with that, just put a 0. This is also equal to 0. So this is x bracket minus 16 minus 1 bracket minus times minus is plus. So 4 plus 28, that is 32 equals 0. And so this is minus 16x minus 32 equals 0. So if you simplify, solve this one out for x, minus 16x will be equal to 32. So x will be 32 over minus 16. So x is equal to minus 2. So if x is minus 2, then the matrix A is going to be a singular matrix. All right, so conclude that the value of x is minus 2. Okay, so that is the concluding part of this. So please, if this is your first time of joining this YouTube channel, please subscribe to my YouTube channel, and as well like the videos, give me thumbs up on the videos, and at the same time recommend this channel also to your friends and everyone around you. Okay, so in the next video I shall be discussing what is called the cofactors of a matrix. Cofactors of a matrix. After that, I will go straight to what is called the adjoint of a matrix, and then we now come down to the inverse of a given matrix. All these three are connected. All right, so and after all of that must have been discussed, then we can move on to solving systems of equation using matrix. All right, so let's see in the next video.